8.2. So the next section is 8.2. This is the longest section for this chapter. So let's just buckle in, clock in, knock it out. But of course, ask questions because there'll be a lot of content in here. So let's start out with, and what we're going to be doing is going over each of the types of printers that we briefly went over in 8.1, starting with inkjet printers. Now, what are some things we remember already that we discussed about inkjet printers? They need every color to work.
They come out like
Martin.
They come out wet.
They come out wet. All right, let's scroll down. Or actually, leave it right there. So they're usually less expensive than laser printers. This is what one looks like. Advantages: the initial cost is low. What has an initial higher cost than an inkjet printer? Laser printers are more expensive initially. They are high resolution. They warm up quickly. However, we're going to learn about how this printer works, and that's with nozzles. And those nozzles are prone to clogging. So that's a disadvantage of an inkjet printer. Ink cartridges can be expensive, and we already said the output, the pages come out wet. We need more time to write? Slightly, okay. All right, moving on. The parts of an inkjet printer. Of course, it uses ink cartridges because it's an inkjet printer. It uses paper, which comes from trees. Next. Here you have the print head. Now the print head goes back and forth, back and forth. And there we can see the various ink cartridges for the various colors. Abdul Shakur. In residential, yes. The most common, like when you go to the next, is a thermal printer. So it depends on which environment.
Like McDonald's.
Like McDonald's. So this print head goes back and forth so you can do the different colors and put the image on the paper. There's two different ways this can be done. Thermal or piezoelectric. So with thermal, how that works is it uses heat to create steam that forces that ink out of the nozzle. Just like before we had cars, we had steam-powered cars. I'm trying to make a reference from earlier. Never mind. So, thermal printers, electricity creates that steam, and that bubble forces the ink out of the nozzle onto the paper. The other way is piezoelectric. It has a crystal that vibrates back and forth, back and forth. And that vibration allows ink to come out of there. So for example, this is a ballpoint pen. On the paper, is ink just flowing out of it? No, but if I move it, then, right, ink comes out, right? So just think of the vibrations, right? That's going to cause the ink to come out of that nozzle and onto the paper with that piezoelectric crystal. Easy day? All right, the next part is the roller. These pull paper in from the feeder and around to various parts within the printer. The next thing we have is a feeder. This can hold our paper until it's ready to be used and pulled in by the rollers. And then we have duplex assembly. Who remembers what duplexing allows us to do? Print on both sides, right? It's going to rotate that paper onto its other side so it can add the ink or toner for a laser printer onto the other side. The next thing we have is the carriage belt. This is what the print head attaches to so you can go back and forth and apply ink to the paper. Now, what are the two ways that ink on an inkjet printer can be placed onto the paper? Thermal and piezoelectric. Which one uses steam and creates a bubble to force it out? Thermal. Which one uses a crystal and vibrations? Piezoelectric. Any questions? Do we need more time to take notes on this section? All right. No. Have you all seen the documentary? Lasers.
How old is it?
It's not from. I don't think it was made this century.
There we go.
You got a lot. You're not wrong. You tried a lot.
I just asked how old it was.
You'll be there someday and know our pain.
Here soon. Looks at me.
Because I didn't hear what you said at first.
What about Brian Sierra? Branch, we call that deflection. Deflecting and redirecting. What about Sierra? Old stick. Ask some of these kids who was doing better at PT than them yesterday.
Who is what?
Ask some of these kids who was doing better at PT than them yesterday.
Ah. We ready? All right. Moving on. Before we do this, what are some advantages of an inkjet printer?
Often
Cheaper initial cost,
quick to warm up,
quick to warm up,
and high resolution.
and high resolution.
You didn't want to let nobody else answer?
All right, Jackson, you're out for disadvantages.
All right.
Someone other than Jackson, what are some disadvantages?
They come out wet.
They come out wet. McCants.
Don't you have to have the ink for that? Like, you have to have all of the ink.
The ink is expensive, and you've got to have all of the ink, yeah? The nozzles are prone to clogging, right? Very, very good. All right, now let's check our understanding on inkjet printers. These are tiny holes in the print head. Nozzles, they are prone to clogging. These are located on the ink reservoir at the back of each nozzle. A charge is applied to cause the crystals to vibrate. This vibration controls the flow of ink on the paper, and this is piezoelectric. I always forget how to pronounce this. Inkjet printers use these to spray ink onto a page. Ink cartridges? Okay. This is located on the carriage, which is attached to a belt and motor. Print head. As rollers pull paper in from the feeder, the belt moves this back and forth across the paper to spray ink on the page. Mirroring thermal? Carriage. A pulse of electrical current is applied to heating chambers around the nozzles. This heat creates a bubble of steam that forces ink out through the nozzle onto the paper. This is thermal. Very good. Turns a page that is already printed on one side, so it can be printed on the other side. Duplex. How are we feeling about inkjet printers? Any questions on inkjet printers? We feel like we know a lot more about inkjet printers now? Yes. All right, that was still pretty quick and still basic, but we're going to move on next to laser printers. They'll get it eventually, maybe. Or they'll be like, they stole that from Mr. Novak, even though it's from before I was born. All right, so laser printers, advantages. This is also, just like inkjet, is a high quality printer. It uses a laser beam to create an image. it has a low cost per page, which you may not think initially because a disadvantage is the initial cost is more than an inkjet printer, right? But you pay more for the laser printer initially, but overall, over time, right, that cost per page is lower. Now, that doesn't mean you should go out and buy a laser printer yourself, right? Calculate your pages per month, etc. It has a high PPM. What's PPM stand for again? Pages per minute. That's our speed. So a laser printer is going to be faster than an inkjet printer. Definitely an advantage of that. And prints come out dry, unlike what type of printer they come out wet? Inkjet. Very good. Disadvantages of a laser printer. High cost of startup. And toner cartridges are expensive, just like what's expensive with inkjet. Ink is expensive in inkjet. What's expensive in laser? Toner. I'll give you a second to write down these advantages and disadvantages of laser printers. While people are writing, again, what are some advantages of laser printers? Cheaper over time. High pages per minute,
High capacity.
which is the high capacity.
Prints
Come out dry. High quality. Disadvantages. Initial cost is high. Toner is expensive. Oh. Spaceballs. Austin Powers. They are, yeah. Are we ready to learn about laser printers? Maybe I should stop so no one gets the reference. That's okay. So, it was kind of easy. The inkjet printers, we talked about two ways that it prints, which was the thermal, creates that steam to force ink out, and the piezoelectric. So we've got to go a little bit more in depth on how a laser printer works and that process. To do that, we've got to talk about all of the various parts of a laser printer first. So here we have, drum roll please, the imaging drum. All right, so this is where the laser is going to etch things on. It's a light-sensitive material. The laser hits the drum. That's the imaging drum. And you can see that this drum is going to be rotating continuously as new images are etched onto that with a laser, with light. The next component we have is toner cartridge. So instead of ink and an inkjet, here we use toner, and of course we're going to have paper. The next thing we have is the fuser assembly. So this has hot rollers that's going to melt the toner into the paper. It's going to be fused together. Notice how on paper you can't peel up the letters, right? It's like the piece of paper and the toner are one thing together. They are permanently fused together. The fuser does that with heat and rollers. The next thing we have is transfer rollers. These assist in moving the toner from the drum onto the paper, which will make more sense when we talk about the laser printing process to transfer it from the drum to the paper. Abdul Shakur.
I don't know what you call it, but like it's like when people make old newspapers and then like press it and then roll it. Is that a form of laser printing?
It uses a similar thing. That they use pressure, compression, right, to move it from one to another, right? Like stamping is how they do that. This we use heat and pressure to move it, and we use electricity, which might make more sense when we go over the laser printing process. Good? I like where your head's at, though. Newton.
I have a question. This is for the last one, but I just thought about this. If the paper is wet and you flip it over and it the duplex assembly flips it over to print on the other side, wouldn't it technically bleed through?
For inkjet, yeah, it could, yeah. So that's something to consider and think about. The next component in a laser printer that we have is Pickup rollers. These are able to move the paper throughout the laser printer for the various parts. There's going to be numerous of these throughout the printer as the paper has to be moved throughout this process for the different steps that we're going to learn about. So that move the paper during the printing process. Next we have duplex assembly. We already know about this, right? A duplex assembly allows us to print on both sides. Would we like more time to write down the parts of the laser printer? Okay. We're going to discuss all of these when we go over the laser printing process, so it's important to know what they are to make that easier. Still writing? Okay. While you're writing, let's think back. What are some advantages of laser printers? Low cost per page, high initial cost. What are some other advantages? High resolution, high ppm, output is dry. Disadvantages, we said one already. The initial cost is high and toner is expensive. A few more seconds. All right, let's check what we know. This is one of the primary consumable items in a laser printer. Toner cartridge. This is made up of hot rollers which melt the toner into the paper. Fuser assembly. These move the sheet of paper out the tray or cassette, then through the printer during printing process. Pickup rollers. This is coated with a light-sensitive insulating material. Imaging drum. This turns a page that is already printed on one side so it can be printed on the other side. Duplexing assembly. And this assists in transferring a toner from the imaging drum to the paper. Transfer roller. Hooyah? Questions? All right, now, the laser printing process. So, the first step, P, click next for me. P, C, E, D, T, F, and C. So go back to the very first one. So I don't have a mnemonic to remember this. So if you can think of one that's class appropriate, we can use it. But PC, ED, TFC. 1, 2, 3, 4, 5, 6, 7.
Please choose every day to feed the cat. Pirates can eat, drink, papers can eat, documents, fight.
And clean.
Pirates can eat, clean, drink, talk.
Actually, that works.
Pirates can eat, drink, talk, fight, and clean.
Papers can eat documents to feed cats.
Papers can eat documents to feed cats.
Printers can eat documents to feed cats.
Printers can eat documents to feed cats. However you want to remember it.
PCs eat data, transfers frequent communication.
come up with one that works for you. And maybe, I don't have a good mnemonic yet, so maybe if the class comes up with a good one, we can use it in future classes. Pirates. What was the pirate one? Pirates can eat,
Drink, talk, fight, and clean.
clean, drink, talk, fight, and clean.
Cheat. It makes more sense for a pirate. Pirates aren't clean.
I don't like that word as a teacher. Cheat. Triggers me. All right, so let's talk about the first step. The P, this is processing. Processing. So whatever mnemonic you're using, processing. So when you print something, that's coming from your phone, your PC, your tablet, wherever, right? Now what allows the the hardware, the printer, to communicate with the operating system? I kind of already said it. It's the driver, right? So just thinking about that. Now, you send something to the printer. Roberts.
Sorry, my road just thinks that I came up with one.
You came up with one. What do you got?
Okay, y'all listening?
Yeah.
Pressure class entering doors together, fooling and cooling.
All right, so he said, pressure class entering doors together, foolin', coolin'.
Fooling and cooling.
I don't know. I like it, but I don't think we're quite there yet. But let's talk about the P. The first step is processing. So when you send a print job to the printer, that's going to be going from your computer, and that's going to go to the RAM on the printer. Now, if everybody prints all at once, there might not be enough RAM on there to store it. That's why you might need a print server that we'll talk about later on. But that job is going to be stored in the printer RAM, so it can be processed. Now, the languages that printers use to print things are very unique because they're creating a real-world product on a piece of paper. So examples of some of these common languages for printers are Adobe PostScript. HP has their PCL, Printer Command Language. What they're going to do is they're going to store a bitmap in the printer's RAM, in the memory, so it knows which color and dots of each color and complexity need to be in each location. So that's what's happening, processing for what the printer is going to need to do. Easy day? Now, what's something that you think could speed up the first step of the laser printing process? What's a piece of hardware we could upgrade then? Your RAM. Easy day? A little bit of time to write this down? Okay. People come every day to figure out computers.
I'm trying.
People come every day to fix computers. All right, the next step is Jackson? Charging. Divya, you want to go to the next one? Charging. So here we can see an image of what we're going to be looking at later on. But here in the center, this is the imaging drum. That's where everything is going to be revolving around, is that imaging drum. So with charging, the image on the drum from the previous print is removed, and it's conditioned for a new image. So it's charging, it's preparing for the new image. The way that it does this is you have a wire, a grid or a roller that receives about negative 600 volts of DC, direct current, across the entire surface of the drum. So this wire is typically called the corona wire. Not the drink, right? But it's called the corona wire. Now this wire gets extremely hot. And even after you've printed and you open up your computer, that wire is hot and dangerous. Besides the lasers, or this may be even the most dangerous part of a laser printer. You open it up, touch it, it could burn all the way to your bone like that, and you're having a bad day. Right? So that corona wire, that's what's negatively charging it to about negative 600 volts to charge, to prepare that drum for the new image. If it's using a roller, it's called a conditioning roller. Cerna. How can you have a negative attitude? Oh. Positive energy, negative. You've got electrons, neutrons, right? You can go negative as well. But wouldn't it be great, like, if negative volts was impossible, it would be great if we could not have a negative attitude.
So would negative volts conduct more energy or no?
It's just opposite. All right, the next step is E, which is exposing. So we just cleaned or charged the drum with that corona wire. Now here, this is really the first part of producing that paper. This drum, the imaging drum, it's photosensitive. So now we're going to expose it with a laser. We do that by, in charging, we do negative 600 volts. Here in exposing, it's negative 100 volts. Now, because this has a lower negative charge than the rest of the drum, we've created an invisible image on the drum for the later steps. We're like sketching it for where the toner is going to be attracted to later on. The drum is continually going to be turning as that laser is going and etching that negative 100 DC volts onto the drum. So that is exposing. Exposing the laser to the drum, negative 100 volts, as it's continually rotating around. Hoo-yeah? The next step is D, which is developing. This is now the first part where toner is introduced for the first time for our page that we're printing. So toner is going to be applied to the drum now. A control blade is going to hold the toner at a microscopic distance between itself and the drum. It's such a small distance, and because we have a higher positive charge on the drum, the toner is going to move to the drum, but only in the places in the previous step, exposing where that laser etched that negative 100 volts onto it. Hoo-yeah? So step one is processing. You print it, the driver sends it to the printer, puts it into a printer language, stores it in the RAM. Charging. Corona wire prepares the drum, removes the previous latent image. E, exposing. The laser etches an invisible negative 100 volts on it for where the toner will eventually go. D, developing. A microscopic distance that will now allow the toner to move to where we exposed earlier. The next step, T, is transferring. Here, with transferring. So currently, before here, now the toner's on the drum, but we've got to get it onto the paper. That's what's happening in the transfer step. Rollers are going to move the paper in and get it close to the imaging drum, and the corona wire places a positive charge on the paper. Now, because the paper is more positively charged than the drum, that toner moves from where it was etched and placed on that drum onto the paper. As the drum is rotating and the paper comes through, and now that toner is transferred from the drum onto the paper because of the positive charge that the corona wire places on the paper. Remember, that's very hot, right? and placing that positive charge. And this is why, part of the reason why your paper comes out warm in a laser printer. Good? So that is transferring. Questions on transferring? More time to write?
Yes.
Okay. Then he started writing.
I know, right? I was trying to listen first.
How you feeling, Wine, too? You miss printers.
I don't.
Take back. Take back.
Jackson? Yeah. Transferring? So in transferring, the toner's on the drum. We want to get it onto the paper. So the corona wire positively charges the paper. We're attracted to positive people, right? Positive things, right? So that toner is like, oh, this is more positive. I'm going to jump from the drum to the more positively charged paper. And the corona wire does that. Charges the paper. It's more positively charged. The toner goes from the drum to the paper.
The corona charges the paper, which tells the drum to put it on the paper.
It's more positively charged, so it's attracted. The toner goes to the more attracted thing. Positively charged. How does charging work? Charging uses the corona wire or primary transfer roller, and it places negative 600 volts DC on the entire surface of the drum. So basically the drum can start over as a blank slate for the next piece of paper. A lot of people going to the head. We need a break, or are we good to continue? Let's finish this. Oh, we didn't do fusing yet. There we go. Fusing, step 6. Fusing. So in transferring, we've transferred the toner to the paper, but now we're going to permanently fuse the toner to the paper in step 6. Fusing. Permanently fused. It's rolled between heated rollers and pressure rollers. So it's simultaneously heated and squeezed, right? So it's warmed up and compacted to permanently fuse that toner onto the paper. After that, the paper is moved out of the printer, and you have your piece of paper. However, there's still one more step in this process, which is 7, and that is cleaning. So step 7 is cleaning. So the paper came out. We don't need that image on the drum anymore. However, there still may be excess toner on that drum. So what's going to happen here is that remaining toner is going to be removed. It may have a blade or use an AC voltage on a wire that removes that excess toner. And nowadays, a lot of them are put into a waste kind of bin, so you can buy another product from the companies in a used bin. So that's the last step. And then it continues on, right, around the circle again, right? So that blade, scrape off the excess or a charge, and then it goes to charging, which redoes the entire surface, and then it keeps going around and around and around. So step 1, processing, puts it in the printer language, stores it in RAM. Charging, negative 600 volts on the entire surface of the drum. Exposing, we use our laser to put a negative 100 volts on. D, developing, the toner is attracted to where we expose it to on the drum. Then the toner that's now on the drum from developing is transferred to the piece of paper via the corona wire, more positively charged. Fusing, permanently fuse that toner to the paper with heat and compression. Heat and pressure. And then finally, as that drum goes around, a blade or a negative or an AC charge will take off that excess toner.
So cleaning is removing the excess toner and the charge that might be on it? Or no?
Just the excess toner. Charging, right, when it continues loop back and around, puts that negative 600 on the drum. It's a lot of stuff here. More time to write, or are we good? All right, let's see what we know. And you all said you wanted a break, right? Okay, we'll do this, then we'll continue. All right, so we need to figure out which step is which. So, when an image has been deposited on the paper and the drum has separated from the paper, the remaining toner must be removed from the drum. A printer might have a blade that scrapes the excess toner. Some printers use an AC voltage on a wire that removes the charge from the drum surface and allows the excess toner to fall away from the drum. The excess toner is stored in a used toner container that's either emptied or discarded. We all said this was cleaning. Step number 7. Okay. The toner attached to the latent image conducted to the paper. A corona wire places a positive charge on the paper. This is... All right, let's keep reading. Because the drum was charged negatively, the toner on the drum is attracted to the more positively charged paper. The image is now on the paper and is held in place by the positive charge. This is transferring. The data from the source must be converted into a printable form. Processing. The printer converts data from the common languages, such as PS or PCL, to a bitmap image stored in the memory of the printer, we said is processing. Next we have the toner is applied to the latent image on the drum. A control blade holds the toner at a microscopic distance from the drum. Developing. The toner then moves from the control blade to the more positively charged latent image on the drum. Yes, this is developing. The next. To write the image, the photosensitive drum is scanned with the laser beam. This is exposing. Let's finish reading the rest of this. Every portion of the drum that is scanned with the light has the surface charge reduced to about negative 100 volts DC. This electric charge has a lower negative charge than the rest of the drum. As the drum turns, an invisible image is created on the drum. Yes, this is exposing. Next, we have the image on the drum is removed, and the drum is conditioned for the new image. This is charging. If we didn't know that, right, maybe this would help us figure out the rest. A wire grid or roller receives approximately negative 600 volts DC uniformly across the surface of the drum. The electrified wire grid is called the primary corona. The roller is called the conditioning roller. And last, the toner is permanently placed on the roller. The printing paper is rolled between a heated roller and a pressure roller. As the paper roll moves through the rollers, the loose toner is melted and combined with the fibers in the paper, becoming one. The paper is then moved out the output tray, which is fusing. Questions on that? Questions on the laser printing process or laser printers overall? No. And we would like a break. All right, continue on 8.2. We talked about laser printers, inkjet printers. Now we're going to talk about thermal printers. So, if you've had a job before, you've probably seen one of these printers. If you've ever purchased anything, you've probably received one of these papers, one of these receipts before. Now, a thermal printer has the printer and it has the paper. It uses heat to create the image. But the image is low resolution, and your options are white and black. So it's not very detailed. You're not going to be printing the Mona Lisa, but on your receipts, you don't need too much information, just some text for the details of your purchases, right? So advantages of these are that there aren't many moving parts. There's no toner. There's no ink. However, the paper has to be stored at room temperature, because if not, then it could get damaged. And you've probably seen these before. If you order a pizza or something, and your receipt, it turns all black, because the way that this paper works is with heat. So here we have some thermal paper, and if we apply heat, it changes color, right? It can change, and that's what happens. Fire. Good? All right.
You said so it's just a printer and the paper.
Printer and the paper. That is it. Good?
Yes.
All right.
Why did it only change one color on one side?
Because this paper is only on certain sides. Air it out a bit. So if you install this paper wrong, it's not going to print. Everybody good? Smells nice in here. Corzo. There's instructions on the paper, and it'll come out how it's rolled. Yeah, and then you can just, it didn't print. Let me just flip it over. Now you can clean these, because the maintenance on these is pretty easy. You just have to do the, use some isopropyl alcohol, clean the heating element, good to go. Have you all seen these before?
Yes.
Excellent. All right, moving on to the next thing. As long as the smoke alarm doesn't go off. Impact printers. We've talked about these before. So go ahead and let's go to those other images now. So these use a print head to impact the paper. So an example of this is dot matrix. So here we can see various dot matrix. Now what's special about dot matrix printers is they have continuous feed paper. Look at that image on the left and right side. You've got holes punched out. You'd have a box of that paper and it'll continuously be fed in with those holes and then fed out. Your orders in boot camp probably came on those, right? Or maybe not anymore. That's how mine came. All right, another example is a daisy wheel. So here it's got a wheel that'll rotate, and when it gets to that character, and then it'll stop and it will strike the paper. Hoo-ya? All right, let's go back. Obviously, lots of moving parts. These are older printers, not very common today. It is legacy, that's right, because people from the 1900s, they don't like to hear the term old, legacy. We're still relevant. Good to go? All right, next we have, see what we know. Let's check your understanding. So which printer is this? The ribbon strikes the paper, imprinting the character on the paper. Impact. These printers use continuous feed paper and can print carbon copies. Impact. Perforated strips on the side are used to feed the paper and to prevent skewing or shifting. Impact. The heated areas of the print head make the image on the paper. Thermal. This is a no cost, there's no cost for ink or toner. Thermal. Very good. Van Kirk, here's your receipt back. Virtual printers. I thought I clarified you didn't need it back, right? Oh, shoot. We'll talk later. Virtual printers. So these aren't real printers. They're virtual, right? But why would you need a virtual printer? Well, if you need to print to a file. So if instead of printing, when you go to print, you can go to print to PDF. So instead of printing an actual output, you can print it to a file format. Oh, I need this in a PDF. Just go File, Print, and then select PDF, and then it prints it to the file instead of the actual printer. Easy day? So you can do different things. PDF, XPS, so all these just are different formats. We'll move on to the next thing. Cloud printing. This is just remotely printing to the cloud. If you're here at work and you want to print to your home computer, you can do that over the cloud by accessing it. Exactly. That's exactly it. Fancy way of saying remote printing. Let's check our understanding. What was introduced by Microsoft, the XML paper specification format, was meant to be an alternative to PDF. XPS, print to XPS. This allows the user to connect the printer to the web after it is connected. The user can send print jobs to the printer from anywhere that has internet access. Cloud. Print software either sends the job to a file or transmits the information to a remote destination in the cloud for printing. Virtual printing. Not a lot of confidence. The .prn file could be quickly printed at any time without opening the original document. Print to file. To prevent others from easily copying the content in a document, a user can choose to print to this type of file format, such as JPG, print to image. Good to go? Let's scroll down. 3D printers. Let's go to our first video. There's two generic types of printers. There's additive and resin. We're going to learn about all the different parts of 3D printers. But first, let's see it in action and break down to make it a little easier.
This is a 3D printer. It takes three-dimensional models saved on your computer and physically creates them right before your eyes. 3D printers are both fascinating and complex. Each year, the technology gets better and better. In this video, I'd like to walk you through one of these machines to show how it works. My name's Jared. I create 3D animations to show and explain how things work. Hit the subscribe button to be notified about future videos just like this one. This video is sponsored by Bamboo Lab. In science fiction, they sometimes have this device called a replicator. You can ask it to make almost any object, and it somehow materializes right in front of you. Today, we don't have replicators, but the 3D printer is starting to do some of the same things. It doesn't happen instantaneously, but it's still quite impressive at what it can do. 3D printing is a type of additive manufacturing. You start with nothing and then add materials layer by layer until it's complete. Compare that to subtractive manufacturing. Start with block materials such as metal, and you remove parts from it to form a final product. Notice all the excess waste. With additive manufacturing, there is much less waste in materials. This is an advantage to 3D printing. Yes, it's true. A 3D printer can be used to create all sorts of toys, minifigures, moving props, you name it. But keep in mind that a 3D printer can be used to create objects that have more practical use. A lid holder for your kitchen, zip ties, adjustable supports for just about anything, a Wi-Fi QR code sign, and even a customized broom holder. Very useful for your kitchen. You can even 3D print accessories for your 3D printer. We're only limited here by your imagination. In the real world, there are some other interesting uses. 3D printed food, yes, it really is edible. 3D printed clothes, and 3D printed prosthetics for those that need replacement body parts. Large-scale companies are using 3D printing to manufacture products because it's less expensive and quicker to produce. Companies like SpaceX are literally 3D printing parts of their rockets. NASA is hoping to use 3D printing to create items when astronauts are far from home. This means they don't have to bring as many tools and spare parts into space. And there are even 3D printed houses. Instead of plastic, they are made with a special concrete-like material. And yes, people actually live in them. It looks quite nice if you ask me. There are different types of 3D printing. The most common one, and the one used in this video, is called fused deposition modeling, or FDM. It takes a long strand of filament. This is usually some form of plastic, but it really depends on what you're printing. Then it melts it into a specific pattern to form a layer. These layers go one on top of the other until you finally created your 3D object. The filament usually has a thickness of 1.75 millimeters, about the thickness of 2 credit cards. Filament for the printer we'll be looking at today comes in these large spools. You can get them in almost any color that you want. The filament comes in several different types, but don't worry, you don't need to memorize any acronyms here. Just know that PLA, or polylactic acid, is the most common and easiest to get started with. Some of these materials are more rigid, meaning they don't bend. Others are more flexible, and some of the advanced materials have more strength and can withstand extreme conditions. For this video, we're going to walk through the A1 3D printer by a company called Bamboo Lab. This company is really on the cutting edge of technology and has a lot to offer. As of October 2024, the A1 costs $339 US. Bamboo Lab has been working to get these 3D printers into the hands of consumers like you and me. The printer is about as big as a desktop computer. Very easy to put on a desk right next to your workspace. Let's take a closer look at the A1. This part is called the gantry. Your 3D object will be printed on a metallic build plate. This can be removed so that it can be washed or even replaced with a different one. It's held on by strong magnets directly underneath. There is a touch screen right here to control a 3D printer, but you can also control it from another device such as a desktop computer or even your mobile phone. At the top of the machine, there is a plastic support arm that holds the filament spool. The end of the filament is hand-fed into the tube opening shown here. Then through the plastic tube, which connects all the way down to the tool head. Inside, the filament will be melted and come out the very bottom. Inside the tool head, there is a stepper motor, which will spin to pull the filament through to where it is melted. Now, in a regular electric motor, it uses electricity and magnetism to continuously spin in one direction. A stepper motor is different because it can be precisely positioned and will stay there until instructed to move again. There is another stepper motor over here. When this spins, it moves the belt that goes all the way across here. Moving the belt causes the tool head to move left and right. This bar is called the X-axis linear rail. There are 2 threaded rods on each side. You can actually see them if you move in far enough. When they spin, the rail and the tool head move up or down. They call these the Z-axis linear rails. This means the tool head can only move in 2 dimensions, but this is a 3-dimensional printer. For the 3rd dimension, the build plate moves back and forth on the Y-axis. Down below, there is another stepper motor that spins another belt. This is what moves the build plate back and forth. 3 dimensions of movement allows the printer to create your 3D models layer by layer. There is a camera up here to take images of the objects as they are built. You can even make a time-lapse video, which is really fun to watch afterwards. 3D printing can be as short as just a few minutes, or as long as several hours or even a day or 2 if your object is complex enough. The area inside of this imaginary box, this is called the build volume. You can only create 3D objects that fit inside of the build volume. If you want to print something bigger or maybe more complex with more integrated parts, you can still do that. You just have to find a way to print it in several different pieces. 3D printers from Bamboo Lab come with a handful of 3D models ready to print and built into the 3D printer for easy access. This little boat is commonly referred to as a benchy, which is short for benchmark. It's a common first item that you print to test the speed and quality of your printer. To get more 3D objects, you can download them from MakerWorld or one of several other websites. Many of these are completely free. You can also create your own models in 3D software, but this takes a little bit of learning to do so. You can even use 3D scanning to take objects in the real world and create the 3D model. But either way, once you have your 3D model, it needs to be converted into a format that the 3D printer can understand. Your 3D object will probably be in one of these formats. Then you take that and run it through a program called a slicer. This takes your 3D model and splits it into many distinct layers that can be 3D printed. The slicer uses this and produces something called G-code. This is the step-by-step instructions for how the 3D printer should create your 3D object. These are very specific instructions on how to move the stepper motors. This controls where the tool head and build plate moves, as well as when the filament comes out. Fortunately for us, you don't need to understand this G-code. You just need to send it over to the printer and it does the rest. So let's walk through an example and see this in action. Once you press the print button, the build plate starts warming up, as well as the hot end of the nozzle. Inside of the tool head, the stepper motor starts to spin, which pulls the filament through. The part at the bottom, this is called the nozzle. It's the piece that gets really hot. If you're using PLA, one of the most common types of filament, it will heat up to 220 degrees Celsius. Even with the protective cover, you definitely don't want your hands to get near this during the printing process. At this point, the tool head will come over to the left side and begin to purge some of the filament to make sure that it's flowing. This is called purge filament, or informally known as printer poop. Yes, the printer has got to put it somewhere. Many people will actually 3D print a special container to catch all of this purged filament. Now that the filament is flowing, the 3D printer will take additional steps to prepare for printing. One of them is called bed leveling. This is making sure that the build plate is completely level. Any offset could mean flaws in the 3D print. Bed leveling usually takes at least a few minutes. Modern 3D printers make bed leveling automatic, much easier than previous generations of 3D printers. Right before it actually starts printing, it usually draws a few lines at the front to make sure it's still flowing correctly. At the back of the build plate is the nozzle wiper. Make sure the hot end is nice and clean. After all of that, we are finally ready to start printing. The first layer is extra important because it has to stick really well. This is why the build plate is heated. The build plate is usually textured to help it stick a little better, but sometimes a special glue is used. Oftentimes, the printer will draw the outline of the layer first and then the inside. This inside part is called the infill. You could make this part completely solid, but that would be a waste of filament. It's common to do about 15% infill, just enough to give it structure on the inside so that it maintains its shape. When it's done printing, keep in mind that the build plate will be hot, so use caution, but you should be able to grab your new item within a few minutes. It cools pretty quick. Here's the A1 3D printer in action. Let's take a look at this 3D model. When printing the overhanging portion of this model, it would be necessary to print into thin air, which is not possible. For something like this to print correctly, it needs to have supports added. It's the green tree-like structure that you see here. Another example, let's try to print the gateway arch. In my last video, we saw that during the construction, it would have collapsed without using extra supports. The 3D printer is doing this at a much smaller scale, but the same idea still applies. The Bamboo Lab software allows us to add supports that will be printed along with the original model. You'll notice that the 3D printer does okay with some overhang, but once it gets to the top, we need those supports. When it's done printing, the supports can be broken off. Look at that, 3D printed gateway arch. There was a time when you could only print 3D objects in one color, but the A1 3D printer has the ability to print in several different colors. For this to work, you need a separate device called the AMS light. That stands for Automatic Material System. This connects directly to the A1 printer. You have room for 4 different filament spools. And then there are 4 clear plastic tubes that connect the AMS light to the A1 printer. This is called the filament hub. The end of each filament spool is fed into the holes inside the AMS light, and a motor starts pulling it through the tube. Filament spools from Bamboo Lab have an RFID chip. Using this, the machine automatically knows the type and color of filament. Very convenient, so you don't have to manually enter this. When it starts preparing to print, the AMS light will push the first filament through and the melting process begins. The 3D printer will warm up and calibrate just like we've seen before. When that's done, we're ready to start our 3D print. At some point, the printer gets to a place where it needs to switch colors. The tool head moves over to the side, it will press this lever, against this piece sticking out here. Inside the tool head, you can see that pressing the lever cuts the filament. The filament is now retracted up until about here. Then the second color is pushed into place. Notice how we still have a bit of old filament inside of the nozzle. We can't start printing until we get rid of this. The tool head moves over to the other side to get rid of this extra filament. Let's take a closer look at what happens on this side. We have a small lever here. When this lever is pressed, it moves the sweep. The tool head moves over and presses this lever. Then the purged filament comes out. It has to do this long enough to completely get rid of the old color. When the tool head moves back, the sweep will get rid of the purged filament. Now the printer is ready to continue with the next color. This was a simple 3D print because the filament really only had to change once. Now take something like this. The color will need to be switched many times on an object like this. It takes longer and there is a lot more waste. But that's the trade-off to get your 3D objects printed in several different colors. The A1 is an entry-level 3D printer. You can do a lot with it, but there are some downsides. It's informally known as a bed slinger. This is because the build plate actually moves back and forth. This means you'll need to plan for a little more counter space. And the rapid moving back and forth can sometimes be a problem when you start printing out larger 3D models. It's also 3D printing out in the open. There's no walls enclosing this area. That makes it impossible to control the temperature and humidity during the printing process.
Every small business owner has a...
Let's take a look at one of the more upgraded 3D printers that solves some of these issues, the X1 Carbon, also made by Bamboo Lab. A more expensive model, but there are many advantages to this. The first thing is that it's fully enclosed to control the climate inside. There is a glass panel on top and a glass door in the front to access the inside. Up at the very top is the tool head. It can handle higher temperatures, giving you finer control over the materials and quality of the final print. The X1 Carbon is referred to as a Core XY. The tool head does the moving on the X and Y axes, and the build plate moves up and down on the Z axis. Compare that to the A1 bed slinger that we saw earlier, rapidly moving the build plate back and forth. The X1 Carbon provides a lot more stability, rapidly moving the tool head, but slowly moving the build plate up and down as 3D objects are printed. The X1 Carbon has 3 threaded rods. When these spin, it moves the build plate up or down. The X1 Carbon uses something called LiDAR, which will scan the first layer to check for any problems. On the side, there is an improved camera that will monitor the rest of the printing process and take time-lapse videos. It is a bit darker inside just because it's enclosed, but the chamber LED light makes it so you can see a little better. Here's the fan to better control the temperature and filter the air in the chamber. On top, you can usually put your AMS to print in multiple colors. Notice on the A1 printer we had the AMS light, but this one is just called the AMS. It has a lid to fully enclose your filament spools. This keeps out the moisture, allowing for a higher quality of 3D prints. If you're interested in a 3D printer similar to the one shown in this video, click the link in the description below. The future of 3D printing has never looked brighter.
I think I need one. I think I need one.
Alright.
That's the coolest thing. I think I need
Do you like, we like that video? Okay. So that's additive printer. Let's look at a resin printer. This video is significantly shorter.
Hey guys, welcome to part 1 of my easy step-by-step guide to 3D printing. A basic understanding of how 3D printing works is very useful if you want to understand why prints might succeed and, just as importantly, why they might fail. So today we're going to have a brief and simplified look at the process. It begins not with the printer, but with the resin. There's lots of different sorts, colours and brands out there, but they all have one thing in common. 3D resins are liquids which become solid when exposed to UV light. Now UV light is pretty much everywhere that there's daylight. So keep that in mind. Resins come in opaque bottles for this reason. So if you leave the lid of your printer or store your resin in a transparent bottle, you'll soon have a sturdy paperweight on your hands. And despite what people might tell you, you do not need direct sunlight. This lot froze inside my home on a windowsill that gets no direct sunlight. A 3D printer is essentially a device that controls the process of UV curing. Inside the base of an average printer, you'll find banks of LEDs, a laser, or even a projector, all of which emit UV light in patterns focused through a screen. As printing on top of this screen would ruin it and make printing a pretty costly affair, prints are constructed on removable build plates. The build plate is connected to what's called a Xeon, and this is raised and lowered by the turning of a screw thread. To contain the liquid resin, a tray sits between the screen and the build plate. These resin trays have a transparent film across the bottom known as an FEP. Now, these are developing even as I'm speaking, and are often given fancier names. But think of them as FEPs or FEPs, as they do the same job. These are generally flexible and taut like a drum. During a typical print run, the build plate is lowered on the Xeon and plunged into the resin. It's lowered until it's in very close proximity to the FEP. At that point, UV light is projected in a specified pattern, and when this occurs, the resin hardens, sandwiched between the build plate and the FEP. The thickness of this print is very thin, typically around 1/20th of a millimetre. The UV light then turns off and the build plate pulls away steadily. As it does, the print peels from the FEP and remains fixed on the build plate. If you listen carefully during the printing process, you can often hear this as a small tapping or ripping sound, which is perfectly normal. One layer has now been printed, and it may have only taken a few seconds. However, prints typically require hundreds or even thousands of layers, each printed on top of the last. The size of the layer doesn't matter. It takes the same amount of time to print a layer this size as it does to print a layer this size, which makes resin printing a relatively fast process. For the second layer, the build plate once again descends, but this time not quite as far. The UV light fires, the resin hardens, and the second layer bonds to the first one and is completed. And so the process repeats again. Over a period of time, the prints build in layers, rising from the resin tray fixed firmly to the build plate. With the majority of printers, the print is formed upside down, hanging in place and dripping resin into the tray below. So gravity is always trying to pull the print from the plate. There's also a small amount of suction tugging on the print each time it rises from the FEP. But if the print is supported properly and the build plate is nice and level, it survives these forces and creates a successful print. But if the print isn't properly supported, or if the build plate isn't correctly fitted and levelled, the print fails, becoming an ugly blob on the FEP. Once complete, the build plate is removed and the print is freed from it. It's then cleaned, often in an alcohol-based solution, to remove any uncured resin. Finally, it's set with an exposure of more UV light. And that, in a nutshell, is that. So we now have a basic idea of how the resin printing process works, and we've also got an idea about why resin prints might fail. There are other reasons, but plate levelling is one of the most common. So in the next video, we'll take
We probably didn't like that video as much. But resin printing is cool. Questions? All right, let's dive into Serna.
Does it depend on the type of filament that you're using to impact the durability of
Yes.
the 3D print?
Yep, yep. McCants.
So why would somebody choose a resin over the other ones? Like the resin printer?
Higher quality prints.
Really?
Mm-hmm.
The resin has better quality?
Mm-hmm. But it's you've got to do multiple steps to do it. So it's not like, you just set it and then you can take it off and it's printed. So, all right, let's look at, so we learned a lot more in depth than we needed to. So now that we've seen the whole picture, let's look at the different characteristics of a 3D printer. So starting, here's a picture of one. We've already seen a video. So let's keep scrolling down. Parts. We know we have the filament, depending on which plastic you're going to use, types of plastic or materials, and colors. The next thing we have is the feeder that takes the filament into a tube so it can go into the printer, into the hot nozzle. Next part we have, first, Serna.
Can the feeder have the same issue as an inkjet printer where it gets
Clogged?
clogged?
Yes,
or-
yes, it can.
Okay,
Yeah.
cool.
Here's the hot nozzle. This is where your filament is heated to the correct temperature. Now, this temperature varies based off of which filament that you are using. Also, this hot nozzle, you may not think it, but this is also a consumable that degrades over time, etc. Doesn't get to the right temperatures. So the hot nozzle is a consumable, replaceable part. Next we have the axis. We saw this in the video. To move the filament where it needs to go to create that 3D object. And we have the print bed. We saw that it needs to be level. We saw the different coatings. That's where that 3D object is going to be created. Okay? No? Everybody good?
Yes.
So everything we've watched in those videos, didn't need to know, that stuff should seem pretty basic now that we've dived really deep into it, right? With us? All right. This is the platform onto which the heated filament will form the object. Print head.
Bed.
Print bed. This pulls down the filament to be heated and to exit through the hot nozzle. Feeder. When the filament is heated to the correct temperature, it is extruded from this. Hot nozzle, which we know is a consumable. This can be vertical or horizontal so that the hot nozzle can be located within a specified location in a 3D environment to print the object. Access. This is the material used in 3D printers to create objects. Filament. Questions? No. All right, moving on. That is it for 8.2. Any questions?